Now we'll discuss this question. In this question, they have given that the Lagrangian for a particular system can be written in this form, and they are asking us the equations of motion in the first part of the question. So, how do you find the equation of motion? We know our Euler-Lagrange equation, which is del L by del T, del L at del Q I dot minus del L by del Qi, where Qi is nothing but the generalized coordinate and Qi dot is the generalized velocity. In this case, Qi is nothing but x comma y, because as you can see there are two coordinates x and y, and similarly Qi dot is nothing but x dot comma y dot. So we'll get we have to perform Euler-Lagrangian equation two times, one time with respect to x and one time with respect to y. So the first thing we have to do is, let us find del x dot. What is this value? To find this value, I'm just copy pasting the Lagrangian here. Okay, we have this Lagrangian. So if we differentiate by x dot, what will happen? As you can see, the first term m by 2 into this is a x dot whole square. So this will become 2a x dot, and the next term will become plus 2b y dot. Okay, because we are partially differentiating with respect to x dot, and this term will become 0 minus k by 2. And here there is no x dot dependency. Here there is only x and y term. There is no x dot term at all. So this fully will become 0. So we'll get this equation, m into ax dot plus by dot. Okay, this is our del L by del x dot equation. Similarly, if you find del L by del x, here there is no x term in this whole thing. So this whole thing will be 0. And we have the next thing, minus k by 2 into 2ax plus 2by. Now we are ready to form our Euler-Lagrange equations. So Euler-Lagrange equation says that d by dt of del L by del x dot minus del L by del x is equal to 0. So we just have to substitute everything over here. Now what is d by dt of del x dot? This we can easily find out to be m into ax double dot plus by double dot minus k by 2 will become plus k by 2 into 2ax plus 2by. Okay, this I can simplify and write it in this fashion. Write it as ax plus by is equal to m into, okay, here this should be equal to 0. Okay, and this would be m into ax double dot plus by double dot. This is your first equation which you are getting when you find the Euler-Lagrange equation with respect to x, when you are forming the equation with respect to x. Now what is the next variable we have? We have y. So next set of Euler-Lagrange equation we are forming with respect to y and y dash. Okay, so similarly if we do, we will get del L by del y dash del y dot as, again, this is Lagrangian equation we need to know. Okay. So this one we will get it as you can see here, it will be similarly m by 2 and 0 plus 2b x dot plus 2c y dot, and again the rest of the terms will be 0 because there is no y dot dependencies in this whole term. Now similarly if you do for del L by del y, you will get minus k by 2 into 2bx plus 2cy. And similarly, if you form the Euler-Lagrange equation for this, which is nothing but dy dt of del L by del y minus del L by del Y equals 0. If you form this equation and if you substitute everything similar to that case, you will get this equation. Okay, these two are the equations of motion that is being asked in this question. Okay, now they are asking examine particularly the two cases where A and C are 0 and B is equal to 0 and C is equal to minus A. Okay, so let us take the first case A is equal to C is equal to 0. So I'm just writing the both equations which I obtained at one place. Now, if A is equal to C is equal to 0, the first equation will become something like this. Okay. The second equation will also become, okay, in second equation the A will be 0. So second equation will become minus Vy is equal to MVy double dot. So this will become My double dot is equal to minus Ky. Okay. Similarly, you can do the same thing for B is equal to 0 and C is equal to minus A. Okay. There won't be any difference. Like you can do it. Like it is just the same thing. The result of that I'll write here. Okay. Let me do that also. If B is equal to 0, comma C is equal to minus A, we get um, from the first equation, we will get this one. Okay. And from the second equation, we will get this one. Sorry, that should be minus A also. Okay. This is the same thing as just substituting B is equal to 0 and C is equal to minus A in these two equations, and from that we will get these two equations. So this part of the question is also over. Now, what is the physical system described by the above Lagrangian they are asking? Okay, first before talking about the general Lagrangian, let us talk about this equation which we have got. What is this equation? As you can recognize this, this is just what is x double dot? X double dot is nothing but acceleration, right? Because x dot is velocity, so x double dot is acceleration. So this is just ma, which is equal to force, which is equal to minus kx. Force is equal to minus kx is just the spring force which we have studied in class 12. This is the spring force. Spring force is also called the harmonic oscillator. So this thing represents harmonic oscillator. Similarly, this thing also represents harmonic oscillator. Now, if you see this thing, this also represents an harmonic oscillator, but just in a different coordinate. For example, let me take this equation. So in this equation, what I'm doing is I'm just doing a coordinate transformation. I'm just telling that bx plus cy is my new coordinate. I'm calling it as v. So it will be minus kv is equal to m. What is v dot? V dot will be bx dot plus cy dot. Similarly, v double dot will be bx double dot plus cy double dot. So this will be v double dot. Now, as you can see, this is also same our simple harmonic motion, or you can say harmonic oscillator equation. Okay, so this Lagrangian represents the equation of an harmonic oscillator. Okay, so this part is also done. What is the significance of the condition? B square is not equal to, okay, B square minus AC is not equal to 0. Okay, Okay, okay. By the way, this harmonic, as you can see, this thing is actually represents a simple harmonic motion or harmonic oscillatory equation, and this thing also represents an harmonic oscillatory equation. So this Lagrangian is actually the combination of two harmonic oscillators. It might be like one harmonic oscillatory equation in this direction and one more oscillatory equation in this direction. So this our Lagrangian represents that in a general case. Now, if B is not, if B square is equal to AC, let us just analyze that condition now. So they are saying that B square minus AC is not equal to 0. What does this condition signify? They are asking. So let us see what does B square is equal to AC signify. So this means that B is equal to root AC. Okay. Now I'm going to substitute B is equal to root AC in these two equations, these two red equations. So I will get this one minus K into root ACX plus CY is equal to M BX double dot plus CY double dot. Similarly, in the next, okay, here it should not be B, it should be root AC because I'm substituting it as root AC. Root AC. That's fine. So the next equation, again, I'm writing it as A minus K uh, AX plus root AC Y is equal to root M AX double dot plus root AC y double dot. Now, very important thing. Now what I'm doing, I'm going to divide this first equation by root C. Let us say I'm dividing this first equation on both sides by root C. So I'm writing root AX plus root CY is equal to M root AX double dot plus root C Y double dot. Yeah. The second equation I'm dividing both sides by root A. Okay. Now is the interesting thing. Previously, we had two different equations. So I said that this one represents an harmonic oscillator in one direction, and this one represents a harmonic oscillator in some other direction, this or this some other direction. And these two equations together, the combination of these two harmonic oscillations represents our Lagrangian. But as you can see here, this also represents an harmonic oscillator, but this equation also represents the exact same harmonic oscillator. So if this is in this direction, then this equation will also be in this direction. So if this condition is satisfied, then we actually get an harmonic oscillator, or the whole problem converts into a one-dimensional motion. Previously, we had a two-dimensional motion because we have two equations in different directions. So the whole Lagrangian represented a two-dimensional motion. But since here we have uh, two exactly same equation, this equation will represent an harmonic oscillator in some direction. If we do a coordinate transformation for this, if we do a coordinate transformation for this, we will get K U is equal to M U double dot, where U is equal to root A X plus root C Y. So in this case, uh, this equation represents an harmonic oscillator equation, as you can see here. And this also represents the exact same harmonic oscillator equation. And these two won't combine to give the equation in two dimension, but it will give in same. So this equation will become a one-dimensional equation if this condition is satisfied. That's why this is significant. That's the significance of this condition.